So now I'll spend some time actually doing some application here. So I'll walk through the first one with you. And notice when we are looking at this data given to us, notice that we have to have some assumptions. So number one, we're going to use this given information to compare the moon to the Earth and Jupiter. So it doesn't say how we're going to compare yet, but we are going to do two types of comparisons. One is that we're going to see pretty much diameters, how diameters compare. And we're also going to check volume, that is how big the Earth is compared to the moon and how many moons can fit inside the Earth, etc. Please make note also of some assumptions that we're having. Assumptions. Assumptions, of course, are things that you are just going to accept without proof. But notice here, there are two assumptions just right up here in the top. First off, is the moon a sphere? No, it's not. And none of them are actually spheres. We call them spheres because that's an assumption. We're rounding, we're estimating, because we have no formula for a really crazy crater-filled planet or planetoid. Same over here. We're also assuming average right here, the average radius. Because the radius just means from the center out to the actual edge of the moon or the edge of the Earth. But notice that the Earth has crests and valleys, so where am I going to be checking my radius? So we have to do some sort of average radius. So those are some assumptions that we're approaching here. So we're going to look at the moon, then we'll calculate things about the Earth and Jupiter and also do some comparison. So first off, let's answer this one question right here. How many moons can stretch across the Earth? How many moons can stretch across the Earth? So what's that look like? So if I just have the Earth right here, and I want to know just how many moons stretch across this. So we're talking two-dimensional, and this is clearly not to scale. So in other words, I'm comparing the diameters, right? Comparing the diameters. So let's just check right here. All right, so how many moons do fit across? This is my radius of the moon, 1,079. And then this is the Earth there. So how are we going to compute that? So how many moons can stretch across the Earth? This question is about diameter. So the diameter of the Earth compared to the diameter of the moon. Or divided by. So the diameter of the Earth is, so here we get 7918, and the diameter here is 2158. And we get approximately, so I'm going to change that, approximately, and 3.67. So nearly 4 moons go all the way across. So clearly this is not drawn to scale. So if we look two-dimensionally, the moon is pretty large compared to the Earth. It's only 4 of them across. But let's talk volume now. If I melted down the moon and started putting a bunch of them into the center of the Earth, let's calculate the volume here. So the volume, of course, we're going to use the volume formula, which is 4/3 pi r cubed. So now we're going to substitute in the 1079, and notice it's going to get large quick. So I'm not going to bother writing all that stuff down after this, except for the actual answer. So punch all this right here into my calculator. 1079 cube times pi times 4 divided by 3. So let's write down all the numbers, and then we'll figure out if it's millions or trillions or gazillions. 526,202,543,9. And now let's find our places. So, what is it? So roughly 5.3 billion. So we're going to come back to that number. Notice it's pretty much an exact number. We can type that in later. You could also store it if you know how to put it in memory, because we're going to come back to that number in just a minute. So here we have the question that says how many moons can fit in the Earth. So what we're going to do is find the volume of the Earth and we're going to divide that by the volume of the moon. And we're going to get an approximate value. So notice here, stretching across, it's not quite 4 moons can stretch across the Earth. However, we're going to figure out how many moons can fit in. And holy cow, these numbers are huge. So kind of hard to estimate. I mean, I would guess, what, 20, 30? I'm not quite sure. So let's find the volume of the Earth now. Volume is 4/3 pi r cubed. Substitute in the 3959, and then we're going to find the approximate value by plugging it all into the computer. It's an extremely large number, so let's go ahead and put my commas in. And here we are at millions, billions. So here's millions, so billions. So 260 billion compared to 5.3 billion. So all we now do is take those two numbers, and I'm not going to write them out again because that's going to take me half of tomorrow. So this 260 billion divided by 5.3 billion. So that's what's going to go right over here. So with your calculator, just go ahead and take the number that's in your calculator now and divide it by this 5262, etc. So when I finish this, I end up with approximately 49.4. So how many moons can fit in the Earth? 49.4 moons can fit inside the Earth. So now what you're going to do is do that exact same thing here. How many Earths can fit across Jupiter? Because Jupiter is quite large, and Jupiter's awesome for our solar system because as a whole bunch of junk comes in, so here's the sun, and here's the itty-bitty planets that we live on, and then Jupiter's hanging out huge out here. And what happens is that as a bunch of junk comes in through the solar system, a lot of it hits Jupiter. Jupiter's like a big shield for us because it has so much gravity that stuff gets pulled to it and not so much to us here. So it acts quite a bit as a shield for our defenses. All right, so what you're going to now do is just compare, again, how many Earths stretch across Jupiter and then how many Earths can fit inside Jupiter. My advice to you, of course, is when you do find the volume here, don't bother writing it out like this. Keep your answer at, 2 whatever, but times 10 to the, you're going to get a big number there. And in your calculator, it's going to say E12 or something like that. So keep it in scientific notation. So let's see how that works. So how many Earths can stretch across Jupiter? Well, again, all I do is take the diameters. Now, I don't have to take diameters. I can actually take the radii, the radius of Jupiter, and I'm going to divide it by the radius of Earth. And what's the approximate value that I get? So we get approximately 10.97. So very close. 11 Earths stretch across. Now, let's do a super secret shortcut without spending all our time with that volume stuff. Remember that volume, how many Earths can fit in, is a cube situation. So cube that. So 10.97 cubed. In the end here, I get 1321.1. So 1,300 Earths can fit inside of Jupiter.